You know, for 2 decades, a simple camera bug on a couple of Mars orbiters was just, well, it was considered junk data. But what if that glitch was actually the key to unlocking the secrets of the red planet's weather? Well, we're about to unravel a pretty fascinating story of scientific detective work. Let's dive in.
It sounds like something straight out of science fiction, doesn't it? But that's pretty much exactly what happened. For 20 years, this persistent glitch was just written off as digital noise. But as it turns out, that noise was secretly recording the Martian weather, just waiting for someone to figure out how to listen.
So, let's start with the mystery itself. Imagine you're a scientist, you're looking at pictures of Mars, and for years, you just keep seeing these same strange errors pop up again and again.
Now, these weren't some dramatic mission-ending failures. They were just weird, faint little smears of color that kept appearing in images from 2 different European spacecraft, the Mars Express and the ExoMars orbiter. And for the longest time, everyone just dismissed them as mundane digital artifacts, a ghost in the machine. But then, a team of researchers had a total breakthrough. They started thinking, what if this isn't an error at all? What if it's a clue? The key was understanding how the cameras actually worked in the first place. Okay, so the mechanism behind this glitch is actually surprisingly simple. These cameras build a color picture by taking 3 separate photos, one in red, one in green, and one in blue, and they do it super fast. But the key here is a tiny sub-second delay between each shot. So if you're taking a photo of a mountain that's not moving, everything lines up perfectly. But what if something zips through the frame? Well, that delay means it's in a slightly different spot for each color filter. So when the images are all combined, you get that distinct color smear. The big question was, what was moving so fast on Mars?
The culprits? Dust devils. Yep, these powerful, swirling columns of dust are all over Mars, and they were moving way too quickly for the cameras to capture them cleanly. The so-called glitch was actually the signature of a whirlwind racing across the Martian landscape.
And this realization, it transformed everything. The team suddenly had a way to turn what everyone thought was useless image noise into incredibly valuable scientific data.
The real genius of this method is just how simple it is. I mean, the researchers knew the exact time delay between the color channels, right down to the millisecond. So just by measuring how far the colors were offset in a picture, they could use some basic physics to calculate the precise speed and direction of that dust devil. It's brilliant.
But, to get the full picture, they needed a lot of data. So they trained a neural network to hunt through 20 years of archival images, and it found over 1,000 of these dust devil glitches. This wasn't just some one-off observation, this was a massive survey of Martian weather.
As the lead researcher Valentin Bickel put it, they literally turned noise into signal. I mean, this is what great science is all about, right? Seeing a pattern where everyone else just sees a mistake, and having the creativity to turn that mistake into a discovery.
So what did all this data actually reveal? Well, it's completely changing our understanding of Mars. It turns out the red planet is a much windier, much more active place than our best climate models ever predicted.
Just take a look at this comparison. Scientists have a baseline for the kind of wind force you need to actually kick up dust on Mars. Now, according to the standard climate models, only about 6 of the whirlwinds they saw should have been strong enough. But what did the new measurements show? 124 of them were powerful enough to lift dust. That's not a small correction. That's a massive difference.
So here's the crucial point. Our main tool for predicting Martian weather, this thing called the Mars Climate Database, was getting it wrong, systematically underestimating wind speeds in up to 96% of cases. The reality is that winds strong enough to lift dust are over 20 times more common than we thought, with some of these dust devils being pushed by winds topping 98 miles per hour.
So why does all this matter? Well, because for the very first time, this data allows us to build something we've never had before, a real data-driven weather map for Mars. And that is absolutely critical for the future of exploration.
As the researcher said, dust devils make the invisible visible. It's a great way to put it. By tracking thousands of them, we're not just learning about the whirlwinds themselves, we're actually mapping the patterns of the wind near the surface across the entire planet.
And this new map is already revealing all the hotspots. We can now see that these vast plains, like Amazonas Planitia, and big regions like Tharsis, these are critical sources of the atmospheric dust that actually drives the global climate on Mars. We finally know where all the action is happening.
And that brings us to the most practical application of all this, safety. This isn't just academic. This is a hazard map for future missions. It's going to help us forecast those dangerous planet-encircling dust storms, the kind that ended the Opportunity rover's mission. It'll help us choose safer landing sites, protect sensitive gear like solar panels, and it's already being used to plan the landing of the ExoMars rover.
This entire discovery, this whole thing, came from someone re-examining something that everyone else had ignored for 20 years. It really makes you wonder, doesn't it? As we gather more and more data from all across the solar system, what other incredible breakthroughs are just sitting there right now, in the archives, hiding in plain sight, disguised as nothing more than a glitch?